real quick, all we're going to do is kind of re-review classification again, and then go through a lab exercise, actually building from scratch a COVID-19 X-ray diagnostic application. So being able to look at an X-ray and figure out if this has COVID-19 or not, right, from scratch, right? And we're actually going to be able to do this very, very quickly, okay? So just to re-review again, and I know everyone's seen this slide before, right? We are focused today on classification, right? Based off of, answering the question of what is in the image, right? But not necessarily what or how many objects are in the image or the size of the image, right? So if you notice on the right-hand side, there are no bounding boxes. There is no additional kind of detail. It is about, does this entire image match some type of concept or idea that we're looking for? Is there a dog in the picture? Is there a cat in the picture, right? So not, again, not how many dogs, not how many cats, right? And again, some of these use cases that classification is applied to is full-on content moderation, right? Like, is this entire message, hate speech, or is this okay to publicize? Facial recognition. Does this person exist in the photo, right? Kind of like a celebrity recognition model, and visual search around, again, grouping things together. All right. We're going to today focus on showing how fast our transfer learning actually is, right? I know we talk about this a lot, like, hey, the traditional way of doing things, it can take a lot of time, a lot of effort, a lot of data, right? And with transfer learning, you're starting from, an 18-year-old with a college degree instead of a 2-year-old trying to learn how to speak type of mentality. So today I want to showcase exactly what that literally means, so that, again, when we talk to customers, we have a very good understanding of how to kind of transpose that value onto their scenario, okay? The overall process of creating an AI model is, technically more complex than this, but the big steps are these 4 big things here. And again, we're going to actually walk through all of this stuff really quickly in the lab today, right? So the first one is collecting data, being able to get the right amount of data so that we can train the model, labeling the data, of course. So again, all the models are trained, by example. So you have to be able to give it, a good classification of what COVID looks like versus not COVID, for example, right? So labeling data, how that actually goes about, how we go about doing that. Obviously training the model, making sure it can actually learn from all of the data that we've collected. And then finally, actually, using the model, predicting, evaluating the model, and then how do we, quickly iterate on this as well. All right. So some of the common challenges, again, agility, cost, quality. I'll just be very blunt about this, right? Every solution is targeting these problems, right? So how do we actually map specifically to agility and speeding up the AI process, right? I think, and I'm going to kind of emphasize this a little bit more today than anything else here on this slide. But then by being able to tackle that agility problem, you are able to address cost and quality as well, okay? And then finally, I'm not going to go over like the standard spiel here. I know everyone's done this like 10 times over, right? But what I do want to emphasize here is that every step of the way, the whole purpose of this platform is not just because we're a platform and everything is integrated and that's what differentiates us, right? It's not just about the platform. It's not the fact that it's an AI platform, but specifically more along the lines of an AI deployment platform, meaning that we help speed a customer's AI projects and initiatives and models into production, making it so that they can actually start to extract business value as fast as possible. Being able to input data quickly, being able to label data quickly, right? It's not about being able to label data in every form or fashion and in the most like specific manner per se. It's about how do we actually leverage all these different steps and integrate so that they can actually move it into production quickly and then iterate on that, right? So a lot of other solutions focus on like, here's how easy it is to train a model, right? And that's great. People can train models, people can create models really easily these days, doing it specifically on their own laptops, on their own, non-production environments, and that's not a big deal. But how do you actually operationalize it, right? And once you actually push it into production, that's actually only the phase when you're actually starting to truly extract value out of this initiative and project that you're tackling. Okay, so how do we actually speed everything up as we go through each of these steps here? Okay, so real high level before I jump into the actual lab is some of the key terms, and you've already seen some of this stuff over and over again through demos that I've done, through things that Tom has shown as well. But this concept of here's an application. That's the first thing that we'll create today. That is basically a big bucket, big workspace of where all of our data is going to reside and all of our models, right? So a model is a specific algorithm, right, that can actually analyze and predict certain concepts. And you can have multiple models within an application. And actually, you can nest those models under a full orchestrated workflow as well, so that you can chain two things together, or two or more things together. For example, maybe you want to look at a picture and not just see what's inside of the picture, right, like a dog or cat, but maybe there's some text on top of the picture as well, like a meme, for example, or some type of ad, right? And you want to run those words through a natural language processor to make sure that this is safe for work, right? So you can chain two things together through workflow, through our workflow capabilities. And then finally, concepts, which are the actual classes or ideas that we're trying to extract out of the image. So something as simple as dog, cat, chair, tree, right? So when we talk about concepts and when we talk about how our general model knows over 10,000, 11,000 concepts, this is what we're talking about. It understands all these objects in the real world automatically, okay? Inputting data, that's pretty easy. We're going to just upload some information. And then finally, getting the prediction out, which is, again, not a full-on, black and white yes or no. We have everything, but it's all about confidence levels and basically probability, right? So you've seen this before. You get a picture on the left, and then on the right-hand side, here's what the model thinks of in terms of what's inside of the picture and the probability, right, or the confidence level, right? And you can do a lot of different things with how confident you feel with what the model is returning, and augment any existing processes, right? So if a probability comes back with greater than 98%, I don't want to have a human look at it. I can just shortcut it and feed it into the next step of my, whatever process or application, or I can maybe automatically post it onto my website without having further review. If it's less than that, maybe I want to involve a person to actually physically look at it, right? But just by doing that type of thresholding and difference, you can start to shortcut and save time with your kind of human workforce there, for example. Okay, so from here, we're going to actually go do and create a COVID classification lab. How do we go about creating an app from scratch? Right. First thing is we just go ahead and create an application, and this can be completely arbitrary text here. So we're just going to give it an app ID, and we can call it COVID Sales App. And then this is where the power comes in, right? So this is when we're just selecting our different models. For the first one, for this first classification model step, we're going to select the general workflow. So this is going off of the default model that understands all those 10,000 plus concepts. Okay. After we go and create this application, what we're going to do is create the concepts. So going into the Explorer view here, we can go ahead and easily create two concepts. One called COVID, meaning that this image has COVID, and another one called normal, meaning that this image does not have COVID, effectively, that this looks like a normal X-ray. Right, so being able to create these concepts easily is part of kind of the UI proposition here. And we're going to, at the same time, upload and label all of our data by doing this step here, by going into our details and quickly adding positive examples of COVID-19 X-ray images. So what I have here that is in the lab workshop instructions is how to download this data. And in this folder, we have some training data around, what images look like within what X-rays are labeled as COVID, that have been predefined. Like we know that these images are COVID positive. So by quickly uploading this stuff, right, and we talk about going back to that slide here, ingestion of images, right? That's what exactly we just did here, input of data, right? We quickly uploaded data, and there are a variety of different ways to actually do this as well, by referencing URLs and setting up automatic collectors. But the point is being able to immediately input the data quickly into the application. All right, and we can see here we have our images. We're gonna do the same thing for the normal concept here. Positives, browse, train. Same thing. So by doing this action, we are labeling the data as we are uploading, right? There are a lot of different ways that we can actually do more advanced labeling tasks through obviously Scribe and doing bounding boxes, et cetera, et cetera. But even this kind of simplistic way of uploading, some other tools don't actually have this capability, right? You're having to manually munge CSV files together and associate images with actual like literal tags that have to actually, be mapped properly. So you're having to do a lot of pre-processing before you can even do this step. But as you can see here, this was very pretty lightweight. Create the concept, go into it, add positives, right? And then not only did we, again, upload the data, but we labeled it at the exact same time. Okay. So real quick, if we're to jump into one of these images here, and we look at what our out-of-the-box general model gives us back, it already understands some of these things here, right? Bone, anatomy, frame, radiology, right? But if you notice, there's nothing here about COVID, right? Since COVID is relatively new, right? Relatively as in like the past year, hasn't been incorporated, and in the end, every customer is always going to have something very specific that they want to identify. So how do we leverage this, information that this model already knows to then actually predict if this X-ray actually has COVID or not? All right, so that's the next step. So going back to here, we are now going to go ahead and click the Create Model. All right, and this is where the transfer learning starts to take place. All right, so going back to our slide here, all right, when we talk about Enlight and training models, this activity about creating a model, creating a context-based classifier, which I'm not going to get into exactly what that is, right? But basically, this is just a arbitrary name that we can give it. I don't even know which one this is. I just don't want to use the same one. We are going to select all of our concepts, tune the model a little bit. So basically, based off of what you know about the data, we can turn certain flags on and off to help make the model a little bit more efficient and more accurate. All right, and depending on what you selected beforehand, context-based classifier, visual detector, all these other options that you had before, you get different exposure levels to the amount of technical details that you can have here. But you can see here, this was pretty straightforward. All I did was gave it an arbitrary name. I could have named this model ID Tom, right? Tom's COVID model. It could have easily been that. Selected the concepts that we want to actually train against, which is the normal concept and the COVID concept. and then selecting this option here that I wanted to make. All right. So with that, we've created a model within a few seconds. At the same time, when we train the model, this is where the actual transfer learning is taking place, right? And notice how fast that actually came back. Hitting this train model button, if this was going from doing like a fully, from scratch deep train model, this wouldn't have taken seconds, this wouldn't have taken minutes, but it could have easily taken hours and days, right? And if you think about like what is that data scientist who just hit that train model is doing in that time frame, they could be going for a long extended coffee break, going for a dog walk, or doing something completely unrelated to their job, right? Because all they can do is wait while this model is being trained. Because we're using transfer learning and we can get this model trained so fast, that person can now immediately evaluate and start to test out their model, right? So going back to the concept of speed and agility, right, and making sure that we can get things into production quickly, this constant and immediate feedback is one of the benefits of the platform. All right. So with a push of a button here as well, a click of a button, we can also then evaluate the results of this. I'm not going to go into, again, the specifics of all this stuff, but the whole concept is that we can provide immediate feedback so that you can start to figure out, is your model working? Is your model not working? Quickly and easily, and then iterate on that as soon as possible, such that maybe something was wrong here. I didn't like this. Let me edit my details here. Let me go about adding more data. I can hit save again, and then right away I can train the model again. Right, 2 iterations right away in succession, because the worst thing that could happen is to wait 6 hours, 12 hours, a full week, have it come back, look at the model and be like, oh man, I misclicked, I messed up the configuration of my model, I accidentally mislabeled something, and then having to hit that train model button again and then wait another 6 days. Okay, so what does this actually look like now, right, out of the gate? So if we go back to our Explorer view here and we click on one of our images, so this is still showing, here's our default workflow here with the general model. Again, there's no COVID mentioned here. But if we actually open up our custom model predictions, we can now see that we're actually actively predicting whether or not this X-ray has COVID or not. All right, and this one says that it's normal. If I expand out the annotations piece, this actually confirms that prediction as well, right? If we select a different model or different image, let's see how we do here. This one has 97% confidence that this is COVID. This is something that we are already labeled as COVID as well. So just to elaborate or further prove out the point here, if we upload another image that we have not, that the model has definitely not seen. So if you go back to the COVID data folder, there's a whole nother folder called test. So these images we did not upload. So it's definitely not seen them. So there are no annotations, right? So if we upload a couple images here, let's see how they do. All right, so it's processed. We can see here, these are some of the few images that was just uploaded. If we can see here, annotations, there are no annotations, meaning I never touched this. I never, cheated, quote unquote, and told it, that this had COVID, and then it's just using our annotation to predict off of that. It's doing its own prediction. And we can see here, hey, this has COVID, or 99% confidence rate, right? Let's look at another image real quick. This one thinks it's, almost 100%. Technically, it's probably a little bit less than that. It's just rounding up due to the UI. But again, this actually was able to determine that this had COVID, and apparently the doctor left some scissors in their in their abdomen too. So with that, that's how fast a model can be created from scratch, right? And when we talk about speed and agility, this is what we're talking about: being able to quickly evaluate the success of the model or the inaccuracy of the model even from that perspective. And then being able to quickly modify, do additional annotations, do additional labeling, tweaking the model quickly, and then hitting that train button right away so that you can, again, take advantage of the data as quickly as possible, right? So, for example, we're already seeing more mutations of COVID-19, right? So there's a UK mutation, there's a South Africa mutation. Well, what if that actually changes what the X-rays look like, right? So you need to take advantage of the data as soon as possible, because the value of data actually goes precipitously down the longer you wait to use it, right? So you can think of the same analogy as watching Netflix and having those movie and show recommendations pop up, right? If someone is watching Netflix today and then all of a sudden they get like a recommendation for Tiger King, which is like a year ago, that's not what is of present mind of on most people's heads. They're not that interested. They may want to watch Framing Britney right now, right? Hashtag Free Britney. So we want to take advantage of data as fast as possible, right? And being able to iterate on this stuff quickly is the value of having an integrated platform, not just because it's a platform, to be clear, okay?